everyone. I'm Heather. I'm an OpenSciEd teacher and facilitator, and I'm excited to provide you with an overview of Lesson 5 of the Weather Unit. The two investigations in this lesson are really fun to do with students and see their reactions to them. Not only that, they're just a really cool way to make sense of how air moves when it gains or transfers energy. We get to visualize it pretty well with this. So let's get into the lesson. How did we get here? In the previous lesson, we figured out that energy from the sun is absorbed by the ground, which then increases the kinetic energy and therefore the temperature of the particles at the ground. The different ground surfaces heat up differently depending on how much energy from the sun is absorbed. And as the air particles come into contact with the ground, energy is transferred to those particles through conduction. And on a sunny day, the air temperatures above the ground are still cooler than the ground itself. So if those air particles are gaining energy here and they're heating up, what happens to that air once it's heated? Does it stay there? Does it move? Students tend to think that heat rises because we've always heard that. That's the most popular claim that happens, that comes up. So we want to prove it one way or another. Does that happen? And if it does, why does it happen? So in this investigation, we figure it out. There are 2.5 days of this investigation and two big investigations, like I said, that take place. There are a couple of videos that are embedded within the teacher guide, the digital teacher guide. Check those out. One's titled the Soap Bubble Bottle Investigation Setup Video. The other is the Heated Balloon Investigation Setup Video. Again, those are embedded in the materials section of the digital teacher guide. They will save you a lot of time if you check those out. There are 3 main sense-making sections here in this lesson. In the first sense-making loop, we figure out that gases can push on surfaces and cause objects that we see to move as they move. So as we're doing the soap bubble investigation, we're noticing the bubble do different things depending on what the gases inside are doing. The gas particle movement in there depends on how much energy those particles have. And we attempt to make sense of why we saw what we saw in the second section. So we figure out that as those particles gain the energy and heat it up, they not only move faster, but we saw them like spreading out and becoming less dense than surrounding air, which is why we saw that bubble going up and out. But the opposite also happens when the particles have less energy. When there's less energy inside the bottle, we saw the bubble going down like this because there was more energy outside. So we are figuring out why those particles are causing different effects on the bubble. In the third section of the lesson, the third sense-making loop, we use a heated balloon to figure out some more things here. We're using our information from the previous 2 sections and making some predictions about what this parcel of air is going to do, this balloon. We noticed that it behaves similarly to the soap bubbles. It goes up when the particle density inside the balloon is less dense than the air around it. The balloon also sinks down as it loses energy and cools, becoming more dense than the surrounding air. The air parcels outside behave pretty similar to what we're seeing here. So to rephrase this, we're figuring out that the balloon's movement is caused by the behavior of the air particles inside gaining and then transferring energy to that surrounding air around it. So what we figure out in this lesson is that changing the temperature of the parcel of air as a whole causes changes to the air's density due to changes in the kinetic energy or speed and spacing of the molecules that make up that air parcel. Parcels of air that are less dense than the surrounding air are going to rise up, and parcels of air that are more dense than the surrounding air are going to sink down. As they rise, those parcels of warm, less dense air are actually cooling off by transferring thermal energy out into the surrounding air. So some big things we figure out in this lesson. Some key moments in part 4 of the lesson, right after we conduct the balloon or the bubble investigation, we're cleaning up and we're heading up to the science circle to make sense of what we just saw. Instead of doing this on chart paper, I usually do it just on my document camera with the same handout that the students have. Just kind of makes things run a little smoother for me. And if your students didn't already do the CUPS unit, the 6.2 unit, the thermal energy unit before this, it might take a little bit longer, and perhaps make sure that you have some really well thought out questions to ask before we even get into the particle motion stuff, just understanding that like spacing and things a little bit here too. What nuggets of information are they going to need to really move this forward? Be prepared with what questions you want to ask prior to facilitating this discussion. For part 6, we're really focusing here on the energy movement through the system. So We have an open versus closed system situation going on here. Once we seal the bottle with the soap, it becomes a closed system, right? So air can't come in, it can't come out, but it can push on surfaces of the bubble or the bottle itself. We want to focus on how the energy movement affects the particle motion and the forces inside versus outside the bottle. And when I prepare for a modeling discussion like this one, I tend to use the lesson guide examples, just like the one that you're seeing here. This came straight out of the teacher guide. Use this to help you practice doing the model yourself and preparing those questions that you want to ask students before you go and do that with them. Part 8 and 9, as you start the demonstration, look back before you move forward. Ask students to recall what we figured out as the soap bubble or during the soap bubble investigation, and how might some of those ideas apply to this balloon that we have here if we were to heat it up. Predict what we should see happen if we heat the balloon up or add energy to it. Ask students to really think about how this model with the balloon could be like a parcel of air outside. And some tips and tricks with this. I always go to the Dollar Tree and get a couple extra balloons. I watched that video, like I mentioned earlier, and try to get that balloon set up just right. If you do it just right, you should be able to reuse the balloon multiple times throughout the day, as long as it's sealed right. But definitely get yourself a couple of extras just in case, and try it out a few times prior to doing this in front of kiddos. Where do we go from here? The next lesson has students putting everything together from lessons 1 through 5 to model and explain the movement of air in a hail cloud. So we're really in the next lesson just kind of pausing to kind of assess where we're at. So some material management tips and tricks for this one. Use the same model template as the students if you can. I use the dot camera a lot for these modeling situations. Using the dot camera for this just makes it more efficient, and using that look back to move forward tactic, like I mentioned earlier, asking them to think about where were we yesterday? What did we figure out yesterday? How could that apply to today? Might kind of establish that coherence as we move from one part of the lesson to the next, or even from one lesson to the next. It's a good trick. The setup videos, like I mentioned, that are linked in the teacher guide, use those. Watch them before trying to set up things on your own. Like I mentioned before, the Dollar Tree is my go-to for those helium balloons if you don't have your own little helium tank stashed somewhere. I always get a few extra just in case I mess up or let out too much air. Sometimes you don't get the balloon closed back up tight enough and too much air leaks out. But as long as you have it sealed correctly, at the right starting amount, so it's just sitting right at the ground, you can use that same one all day long and it's just fine. So just get a few extras just in case. For word wall management, we really just have a couple words here. The words we earn are density, and words we encounter are air parcel or parcel of air. Poster management, same as before. Driving question board, I always keep visible to help with navigation. And my investigation ideas, always handy to have them to reference for navigation. And if you have any summary tables that you've been making, add to those. But in this lesson, the models of the balloon movement as air is heated and cooled, that is something handy to maybe, if you're not going to keep it visible at all times, like having it on your summary table, or at least stashing that model somewhere so that you can pull it out if you need to reference it later. My students really liked this lesson because we got to try 2 really fun investigations that really helped us see how air moves as a mass when it's heated and cooled, as well as how it heats and how does that even happen. It explains so many other things around us that happen all the time when things get heated up or cool down, transfer their energy out. I hope this video helps you better prepare to do the lesson with your students, and I look forward to seeing you in the lesson 6 video. Thanks for watching.